Hello, my name is Fahim Chowdhury, and in this session I'll be going over JavaScript best practices, mainly the architecture of a project. I'll be talking from industry experience. In my career I've worked on many large and complex projects. So I'll be going over a bit about my background, industry standards such as project organization, architecture. Then I'll go over how these can be applied to JavaScript. So my background. I started coding at a very young age. It was a hobby of mine. So since I was around about 15 years old, I've been coding in Flash, Timeline, and in ActionScript. Also, I was building websites in HTML. I graduated in business and computing degree at university. Then I followed that up with a master's in computer science. My first job was an ActionScript 2 developer and also an ActionScript 3 developer. There was a transition period in that. But also I had to be able to do JavaScript as well. Then as time went on, I turned into a full ActionScript 3 developer for an advertising agency called Ogilvy for many years, and I had to also do a few JavaScript projects along the way. I built very complex applications and games in ActionScript in large teams. But obviously Steve Jobs killed Flash quite a while back, and all of our clients wanted the HTML5 approach and just to drop Flash altogether. The funny thing was we had to develop for IE6 and IE8, which didn't support HTML5. So I transitioned into a pure JavaScript developer, leaving ActionScript behind, and I was tasked to find a solution to develop applications and games as close to the Flash experience as possible. This was at a time when jQuery was the JS king and Prototype JS was the only real alternative. This didn't really suit large-scale games applications that we build. JavaScript was relatively used to build widgets for websites, small-scale components, that kind of thing. Coming from an ActionScript background where the industry had adopted standards and coding methodologies, I wanted to bring this to JavaScript. It was needed for scalability, modularity, and for performance. Though in ActionScript, just like JavaScript now, we used frameworks such as for architecture, such as robot legs, MVCs, and so forth. We still needed a library or a toolkit to provide us with helper methods. It's kind of like a jQuery for pure JS. So we had our own toolkit in ActionScript, which was a library which contained helper methods and also generic components which you can inherit and reskin. In a time when V8 Engine really didn't exist and jQuery animations were very slow, I began to start porting our toolkit to JavaScript because it was relatively solid and it was a library that we spent years putting together. And it wasn't, the thing about it, it wasn't a framework, it was a toolkit with helper methods. You can use any framework you like, any library you liked, and it was so friendly that you just incorporate it to any project. And that was the beauty of the toolkit we had. And we used to generate components all the time and put it in. It was so generic, we can just put it into the toolkit component section and have tons of components ready to be used in the future. So this led to me porting the toolkit to JavaScript, and well, we built some amazing projects, particularly myself, in pure JavaScript that runs almost as good as Flash on IE6 and above. So you can imagine it was working pretty good. The toolkit took about a year to build, still had some bugs to overcome, and in his latter years when we were still developing it, it still had bugs. But I mean, I was mainly doing most of the development. We had a view in the department, kind of a criteria that every project we deliver, we must take something away from it. So if we build modules, they have to be generic enough that you can pull them out and then use it in another project. So that's where, when you have a code abstraction and object orientation, so you have inheritance, you are able to do that. You can just take the generic side of things out and use it in another project, which we'll be talking about in the later chapters. So I wrote 2 books. One was for Toolkit JS Library. That was to help the team understand what it's all about and how it all works and how to use it. And the other one was called Pure JS, which was to help the ActionScript developers transition from Flash to JavaScript. Both of those books are on Google Play and also on Amazon Kindle, so you can check them out. I'll leave the links in the description. So when Toolkit JS was really finished, Knockout JS just came out. It still wasn't defined as a leader in the market. It was just something exciting, and that's particularly how far back in time we're talking in terms of JavaScript. And yeah. And here is some of the clients that I've worked for over the years for various advertising agencies. And so that's my background. Right. Before JavaScript took over the web, ActionScript was the king. All the rich content was created by it. I've been through the life cycle of ActionScript, from when it was a non-object-oriented programming language to a complete OOP language. There are similarities between the JavaScript and the ActionScript lifecycle. JavaScript has been pushed into a more OOP language natively and through libraries. It isn't fully OOP, a fully OOP language in terms of it doesn't have inheritance and so forth. Oh, sorry, it has inheritance, but it doesn't have interfaces, which is quite important. But it's still widely used for complex projects these days, which makes best practices very important. ActionScript has become the leader, or ActionScript became the leader in gaming and all other complex and heavily coded projects back in the day, and that led to the importance of good coding and good coding practices. So what I wanted to start off with is talk about project organization and architecture. ActionScript projects were so big. We had teams of minimum of 5 to 6 developers working on a project to ensure everybody understands where things are in a project and what the roles of each projects are. We had a universal folder structure. It was defined by a team by taking examples from object-oriented languages. Well, it's more like taking industry standards from other places, and also the ActionScript community. And we kind of used the industry standards, but also made it fit our own needs. So there were 2 types of structures that you could use: the sock draw or the modularity, which are very common. And we decided to use the sock draw method. And on screen you can see an example of our folder structure, which was technically a sock draw approach. So on the left hand image you can see it says trunk and a few folders, and underneath it says source. So we'll kind of concentrate on that because in ActionScript that's where all the files are, in the source. So on the next image you'll see it says source, and then you have the hierarchy of folders, and the first one is com, and com historically is the domain name extension. And after that you have Ogilvy, which was the company that I was working for. So you'll have the company name, and then underneath that you will have the client. In this case it was Zurich, and underneath that you'll have the project name, which was Finder. So it's very straightforward. So you have company name, who's developing the code, the client that the code is for, and the project. You can also see on the same level as Ogilvy, there's something called Westside. That was our own toolkit called Westside Toolkit. So when we were inheriting or bringing in components, we will dump it into Westside. So it'll be Westside, and then underneath that it will be component, whichever component that we're going to use. And it's pretty good because if a third party has developed a kind of component and you want to inherit it or utilize the code, you can just put it in, and in the same level as Ogilvy you can have something like Mindshare or something, and then you can kind of clearly see who's done what, where the codes come from. And once you've done that kind of structure, then we go into the project itself. In the right last image in Finder, you can see a kind of more of a linear structure, and we went with this approach rather than kind of a modularity approach because for us we found this easier to navigate through. If you had modularity, you would probably have the components like a carousel in the project itself, and then inside that you'd have services and models and so forth. We found that if you had a service, or if you had something not named according to the actual component, the search for it can be tedious. If you had a carousel component and then inside they had a service called resize service, something like that, it wasn't named correctly, to find it you'll have to go through everything. Yes, you can do a find in your IDE and look for it, but it's just a bit annoying. To make it more easier, everything is within its type folder. So service, all the service scripts are in there. You could then group things into other folders like core, service, and component service, whatever, something like that, and it will work in that sense. And we found that they're very, very easy to navigate, easy to work with. You can get hold of this quite easily. Oh yeah, okay, where's components? There it is. Where's the command? There it is. Everything is in its own place, in the right place. So before you start a line of code, it's very important to plan what you're going to do. This is called code design. You need to create flowcharts to figure out how data will be processed. You need to think about abstraction of your code, as well as finding the right design patterns to suit the needs of your project. UML diagrams will then draw out how the project will be abstracted, and you will then identify issues even before you wrote a piece of code. So it's very helpful, and as I say, 80% is on paper, 20% is actually on screen. So this part is quite vital to your project. Not only will you have documentation for your project, but you will also iron out many issues that will creep up later on. Now if somebody joins your team, it'll be easy for them to understand because they can pick up on documentation, they can pick up on the structure and the architecture of the project. So a flowchart allows you to work out what's required in a given task. With this, you will identify the functionalities you need as well as the views you'll need. So yes, you'll probably know before you start a project, okay, I need this X, Y, Z views, but you may not know exactly all the views you need. like what kind of error messages, what kind of success messages. This flowcharts give you that. So here is an example on screen of the Facebook logging flowchart. Look how effective it is. It's simple chart. It's a simple chart, but immediately it identifies the stages required for the login process, the information required, and how to handle the requests. You can start to figure out what views you need, like login form, success page, and the error page. It also shows you the functionality you need, like the form validation. So this is just a simple example, but with a far more complex flowchart, you'll gain a better understanding of what needs to be done for a given task. From the flowchart, you'll produce a site tree. So you've got all these views that you already know beforehand. Then you add the new views that you just found that through the flowchart. You create your site tree, and this will then list out all the different pages and views that are required for your project. UML diagrams are great to plan your code. You'll list out each class or an object, and you'll easily see the network it creates and how everything fits together. Now you know the views that you need, and from the flowchart you also know the functionality you need. We need to design the code using UML diagrams, and when you're doing this, you need to consider two things: design patterns and abstraction. So UML diagrams, like if the one you see on the screen, it's going to give you a view of your whole architecture and everything that happens, the whole web, and you can immediately identify certain things that need to be broken down, because you'll be listing each object and what's inside the object. You can break it down into and refine things into smaller objects, different types, and when you do that, you are now able to see the whole pattern and link things together you probably wouldn't have seen when you're coding. So it's a very important part of your project architecture. Design patterns provide a good foundation for your architecture, and they are well documented and tried and tested. They essentially provide the core, or they help parts of your project have some kind of basis. You could have a command design pattern where you have commands to do certain things. You might have a factory design pattern to help you create multiple objects. Essentially, this is a guide of how to architect your project. You can choose from many design patterns to write a project: MVC, MVCS, command, factory, all sorts. But how do you know if you need a design pattern or not? It's possible you may not need one, but the bare minimum, you probably use an MVC. Now your requirements will determine your design pattern. So you will see there's no right or wrong choice. You can pick one or multiple design patterns. For example, if you need to have services in your project, you can use MVCS, Model View Controller Service, or even a command pattern. Over the years, I've used many design patterns and combined many into a single project. I've had a project where I've had decorator, singleton, command, iterator, observer, state, many more into one project. And they're universally understood. So, you know, any programming language, any person coming from a different programming language will understand your architecture. Yes, you could go out and create your own vision and way of architecting your project. To be honest, you're probably doing a particular type of design pattern. You just don't know it. But you've done it in a certain way, and you go halfway through the project and it's like, that doesn't really work. They've got issues with this. So it's best to use things that have been used over and over again, and has a kind of a purpose, and people can tell you that it actually works. So that's why design patterns are key, because they've been there and people have used it and it works. Abstraction. Abstraction principle is to remove duplication of code by breaking down the code for reusability and to support polymorphism. Polymorphism is to process objects differently depending on their types. So basically, when you abstract or break down your code, you're simply defining different types for your objects. For example, if you look at the image on screen, if you break down vehicles into types, you'll have cars, bikes, etc. That's polymorphism and abstraction. Looking at the diagram, you can see how vehicles are broken down into air, land, water vehicles, and then they're broken down further into plane, etc., and then broken down another level. This may seem like an overkill in some people's eyes, but this is essential for complex and large-scale applications and projects. When you want to scale up, it will be easier to create another vehicle at any level of abstraction with ease. So the idea is you want to have less duplicated code. If I now want to add a new road vehicle, all I do is inherit from road vehicle, create a new one like bicycle or trike or something like that, and then essentially I give it its properties that it requires. Everything else is inherited, so we've removed any kind of duplicated code. If you now think of how many people would write this without abstraction and polymorphism, you can imagine there will be 10 types of vehicles: car, bike, trucks, and marine, all sorts of vehicles, and each one will have duplicated code. You know, each one has wheels, each one has engine size, and so forth. And you just added 10 times as much as code as you need. If you did abstraction, you probably have one of those objects which has it all, and then the next one has what it needs. So it's very important, if you're thinking about file size, keeping things to a minimum. It's very good for readability, because everything is broken down in small files that you are now creating rather than massive classes. You're creating small classes, and you now have the ability to just scale up whenever you feel like it. You don't have to create a new object that's got all sorts of new functionality in there. You just create another one based on a type of vehicle. Okay, so how do we now apply this to JavaScript? You may have noticed a few things that already exist, or you've seen in JavaScript already. Some of you might have used a sock drawer for your folder structure, or you've used design patterns, which is great. Through this topic, I'm going to show you a comparison between the life cycle of ActionScript and how JavaScript is involved in the same way. ActionScript started off without object orientation and became completely a fully object-oriented language. Then it adopted industry standards, and the same happened with JavaScript. So let's take a look. So JavaScript design patterns. So only recently, due to JavaScript being a leader in web development, many developers who are now JavaScript developers have come from different object-oriented languages, like myself, and are using the same industry standards for their projects. Design patterns are now slowly becoming more important, with all major JavaScript libraries, frameworks, basing their architecture around them. So a lot of major players like Google and so forth, they have libraries and frameworks which are incorporating these industry standards, and by applying design patterns and abstraction and so forth. And most of you guys probably know AngularJS, and probably know that it's been extensively used So let's take a look at AngularJS. So most people would develop in AngularJS are aware of MVC, design pattern, because they're always developing in it. You're always doing .controller and so forth. So controllers, models, and views are all familiar to you. So when you do .controller, you're either creating or accessing a controller. But Angular was traditionally a pure MVC pattern, but now it's an MVVM pattern, a model view model design pattern. It's a similar pattern with a few differences. And another one that people actually know when developing in Angular is the dependency injection. When you create a new controller, for example, and you inject in the $HTTP in the function parameters, this is dependency injection. So there are many more. Decorator pattern is used internally in the library, but you can also execute it by doing $provide.decorator. There is a facade, a singleton, the list goes on. So design patterns are already in use in JavaScript. So I wanted to go over two things. What JavaScript developers are doing right now and what they should be doing. So what are they doing right now? I've seen JavaScript developers write large scripts, over 500 lines of code. I've seen, when I was working in Ogilvy, I've seen we hired like JavaScript developers who were working in the field for 15 years plus, and they'll come in and they'll write code. And I've seen one script which had 15,000 lines of code. That's an extreme case, but wow, that was crazy. But usually they'll write 1,000 to 500. And how they get to that level is because script files are grouped together like controllers into one script, or models or views into one script, or they'll have a main script file which just drags on forever. And essentially, because of JavaScript developers come from a very old school background where broadband wasn't particularly there at the time, it's always been in the mindset file size is a problem. File size is a problem. So they're always looking at the file size being as small as possible. Nowadays, obviously with broadband and so forth, yeah, we do care about the file size, but not to the extreme levels that you will hear a lot of JavaScript developers shouting about, mainly the old school ones. So what should they be doing, or what should they do? So in terms of the large script files, each script should only contain 200 lines of code. Abstraction required if you have more. So if your script is becoming cumbersome and bigger than 200 lines of code, you should think, hang on a minute, maybe I need to break this up. This isn't right. It's good for readability, it's very good for your architecture, and it's easier to maintain. Because clearly if you've got more than 200 lines of code, something else is happening. You know, that's not a service anymore. You're adding things that maybe should be in a controller or something like that. You need to look at your code. And the second thing is, scripts should only contain a class or an object in one script file. So it should be just one controller in the controller script, nothing else. Don't try and group things together. It makes things messy when 3 or 4 people are working on the same project on different scripts. You're all working on the same file. It's going to cause conflicts, merge issues, and it's hard to kind of work when there's other things in the way. There's lots of code, it confuses you. So it's best to keep things one object, one class per file. And also, why worry about file size? You're going to minify your code anyway, and if you're doing abstraction and polymorphism, you're reducing duplication of code. So therefore, your file size should be relatively smaller than it would be otherwise. So I'm sure you guys have seen the example on screen before. So abstraction requires inheritance, and JavaScript has the ability to do this. So you probably know how to do object orientation in JavaScript. You can do it via prototype. It's a very simple example on screen. So you create a person object, provide a first name as a parameter, and store the first name in a variable inside the person object. And that variable becomes it's not inheritable. It's not an inheritable variable. Then, when we put things on the prototype, we're now allowing these objects, functions, variables to be inherited. So we create something called say hello, which is a function. It then logs out the first name. I am, hello, I am, first name. Right, so then what we do is we create two objects, new objects, based on person. The first person will give the name Alice, the second person Bob. So now when we do person1.sayHello, we will retrieve Alice, hi, hello, I'm Alice, log. So that's kind of a simple way of showing you that abstraction can happen on a very small level. If you person, then you can break it down into different types of people and inherit that person, then it can become even better abstraction. So do you remember this diagram that I showed you earlier? This is a simple abstraction diagram. What I'm going to do now is go through this in JavaScript and see how we can do it in JavaScript. So this is how you do excuse me, abstraction in JavaScript, the vehicle abstraction. So first of all you create a vehicle object, and then what we need to do is create variables on the vehicle prototype so they can be inherited, like color and engine size. Then we know that land vehicles inherits from vehicle, so now we'll inherit from vehicle. So land vehicle now inherits from vehicle, and then we'll give it its own variables. So it has wheels. Land vehicles have wheels. After that, we create an object called cars, and cars, we say, okay, cars, just in this example, all cars have 4 wheels. So this object is now created its own variable called wheels. Then that inherits land vehicles, and it then has doors in its prototype, so that could be inherited. So this is how you would do the previous this image here. This is how you do the abstraction for that, and it's doable. And if you think about it, it is reducing code. If you look at how much code you're saving in the long run, this is just a simple example, but you get what I mean. You can actually save tons of duplicated code. So many of you be thinking right now, well, that's great, pure JavaScript, yeah, I can do object orientation, but what if I'm using a library or a framework? Well, don't forget, you're still writing JavaScript. That's the best thing about JavaScript. You can always just use pure JS. So there are many ways you can write or do this. I'm just going to show you an example of how to do abstraction in AngularJS. And there are probably many better ways to do this, but I'm just simplifying the process just to show you how it works. So in this example, I'll show you how to create abstracted services in AngularJS. So first and foremost, I need to create the services in pure.js. So on screen, if you have a look at the code, I create a service object, I create an init function on the prototype, which can be inherited. Then I create a resize service, which then overrides the init method and adds an event listener on the resize, which then executes the resize method on the resize service. And all it does, it logs out resize. So resize service then inherits from service. Great. So we've done it in pure.js. We've created inheritance with the service and the resize service. Now I'm going to show you how to add that to JavaScript, to Angular. So when you create the resize service in Angular, you just create a new resize service and return it within the encapsulated function. So if you look at the example on screen, we create a resize service, and inside the encapsulated function, we now create the new resize service class that we've created, or the object we created. We create a new instance of that, and then call the initialize init function, which will then add the event listener for resize, and then we return the resize service, and that's pretty much it. And that would work pretty well as well. Clean and precise. So on this slide, you can see how to lay out the folder structure. So we've done the abstraction and in AngularJS, and now you're probably thinking, God, how am I going to put this code into my project, and how would it work? So you could. This is just an example, a very simple example. There's many better ways to do it. You could probably create a pure a core folder in the top level, which contains your pure JS files. So service will contain the service class, the resize class, and then outside of core on the top level, you can have all your other Angular JS files. So service will be a folder with Angular JS services, and the resize service will go in there. So it's possible, and it looks cleaner, to be honest. In my opinion, this is a very good way of working, and if everything is abstracted and you're using design patterns, you see that your projects are now very easily scalable. You have minimal issues along the way, and people that come into your project and use your project would understand it better, because you've also got documentation that you already created beforehand. Because you create all this documentation up front, your project's going to run much faster, because all you're doing is working from a piece of paper now. You don't have to think about anything because you've done the hard work in the beginning, and hopefully your projects will go smoother. I have to tell you that I worked in a project where we were building a game. It was a comfort game. It was called Comfort World or Cloth World, something like that, and it was basically trying to recreate Sims in Flash on Facebook. And initially it was given out to one of our third-party development teams to develop the thing. They had a year to do it. They had a bit of a issue where the development team crumbled, and literally 6 weeks before launch, they said it couldn't deliver, which meant it fell upon my team to come up and fix what is an impossible task and get this thing rebuilt from scratch in 6 weeks and delivered. And to be honest, we did, and most of our hard work, late nights, were actually on the architecture, working hard to make sure that everything is where it should be. And when we went to code, we breezed through it. We worked hard a long time. It took, like, every day was like long hours, but we worked through it, and in 6 weeks, not only did we have an application, it was tested, it was working brilliantly. And it was scalable. Afterwards, it was even, you can add more components, and you can add add-ons to the actual gameplay. It wasn't a hack job. And that's why I say this is very important. And from my own personal experiences, this is the way forward, and this is the best way to write code for large-scale applications. So hopefully that gives you a lot of information about how to architect your project. Feel free to send me questions, and I'll maybe do a QA video on YouTube. The slides will be in the description. So thank you all for watching.